All right, today is June 15th. It's about 4 p.m. I'm going to work on this for an hour until just before 5 p.m. Today, I want to see if I can get these two done. I think I'll leave the generalization for next time. I also think of the theory behind that anyway. But yeah, I think if I can calculate the coefficients and then I can probably do a decomposition. Shouldn't be too bad. And I'll add it to the block down here. All right, so first, I should probably change this to Fourier inner product. I'll change this Fourier inner product. And then now I want to do the decomposition. Or, sorry, Fourier coefficients. Efficients. There we go. And I guess I'll take F, G, A, and B. And this will be a list of floats. Returns the first. Well, let me think about Fourier coefficients. I need F, obviously. I need G. Yeah, I need A and B. And then I'll have N. The first N coefficients for the decomposition of F. Oh, I don't need even G. I don't need G. I need just F, A, B, N. And then precondition. Well, obviously N greater or equal to 1. And F is defined for at least 2 points. Otherwise, it doesn't really make sense. Great. Okay, let me think about the math about this real quick. So to calculate the coefficients for each, since we know the Fourier basis is an orthonormal basis, I need to write down the math here real quick. Yeah, I'll write the math here, and I'll put the screen here as well. I kind of forget how orthonormal bases work. So okay, I'll let x1, xn be a orthonormal basis. And I want to be able to represent any x in Rn as these with their coefficients. So basically, I'm solving for ax1 plus anxn. I'm solving for a1 to an. Orthonormal basis. Let me think. This is probably just, so this is the sum from I if I want to isolate for AI. Okay, for each xi, this inner product will give me this. And this gives me this. Oh, sorry, this should be a different variable. I'll call this j. I just didn't make sure my theory here works. Otherwise, it's kind of like futile. Since I know this is orthonormal, I know I can eliminate all the terms that are not I. Okay, and this cancels out. Okay, so I literally just compute the inner product of our function. So this would be our function f, and whichever, you know, one we're looking at. Okay, great, that's great. Awesome. So then in that case, okay, hold on, let me just, okay. In that case, what I'll do is, I'll have a loop for each. All right, well, index is equal to 0. All right, I'll start at 1, while index is less than or equal to n. And basically, okay, wait, coefficients equals an empty list. And then at the end, I'll return coefficients. Would this be coefficients dot append Fourier inner product g is equal to function, define Fourier function. I'll have index a and b on a. Fourier inner product of, we have f, we have g, we have a and b. That works. And then we have index plus equals 1. Now this should work actually. I think this should work. It looks simple, but I think that's it. Okay. Yeah, what I want is, okay, now let me just make sure this works. What's a good, let's take f at x is equal to, let's say 1 plus sine of 4 pi x plus 4 cos 2 pi x. This is the function I want. Okay, so we're going to define a function from 0 to 1. Let's just do 0 to 1. Okay, let me just copy some code from here. So we have increment index equals 0, increment is equal to 1 over 100. Well, index is less than 1. F at index is equal to 1 plus math sine 2 to the 4 times math pi let's say 2. This coefficient should be 2. This will be 2, and then we have 4 times, and it's basically the same thing. Math.cos, and this should be 2. Okay, so we should should get 1, 0, 4, 1, 0, 0, 0. Approximately, right? Okay. Co-f is equal to Fourier coefficients. Okay, let's pass in f. Let's pass in 0, let's pass in 1, let's pass in 1, 2, 3, 4, 5, 6, 7. Okay, and then print coefficient. Is this gonna work? Please. Wait, I ran the wrong thing. That's my, okay. Okay, I'm like relatively close. I mean, these are all zeros, right? So this is 1, 2, 0. I got 0, 2, 1. I mean, is that the same function? 0, 2. Doesn't seem right. I mean, this should be 1, first of all, because that's the very first element. Oh, what did I do wrong? Let's see. Oh. I probably, index should be 0. It should start at 0 and it should go up to n. Right. My bad. That's my bad. 1, 0, 2, 1. One, 0, 2. Then 1. It's slightly off. Hey, that's pretty cool though. That's pretty cool. Hold on. So 1 is, they got 1 correct. 2, 1, 0, 0, 0. Because it should get, oh sorry, this should be 2. It should get 4, 2, 0, 0, 0. It's a little off. This is the Fourier basis, yeah? Yeah, I mean, there's quite a difference. This is a decomposition it got. Okay, well, clearly something's not working out here. What's the issue? Okay, it turns out I misunderstood Fourier theory. Apparently, I have to normalize the coefficients afterwards as well, which is defined by the integral, or not the integral, by the domain. And the way it works is, I guess, for coefficients, I guess I added here. Normalize equals, it'd be b minus a, right? This is like the distance of the interval. And for hold on, let's call this co is equal to this. If index is equal to 0, then I'll coefficients dot append co divided by and be normalized. And then otherwise, I guess, so this is if index is greater or equal to 1, then we gotta normalize by, what is it, 2 times? Or 2 times the coefficient divided by normalize. Yeah. I'll have to do more research into that afterwards. For now, I'll take their word for it. Or I guess Fourier's word for it. I'm sure he's right, because in this case, it should give me the right answer, yeah? There we go, yeah. So yeah, I just misunderstood the theory, which is a little silly. But it works now, which is pretty cool. Wait, no, so now I can like give them like a crazy... what if I give him... Wait, cos 2 pi x. If I paste this into Desmos, does this work? If I copy this, okay, this is the idea. This is the idea I want to do. I want to take in some function, and then I want to output function output Fourier decomposition, and Desmos will be set to true or false. And if it's Desmos, then I'll just add like the Desmos flair to it, so I can paste into Desmos as check. Or I guess it's bool, not boolean. This will return string. Missing doc string returns the string representation of the function's decomposition. If Desmos is true, then return the string that allows direct pasting of Desmos. Okay. Hold on. First, I need to study Desmos theory. Cos 2. So this is shown as cos left. Okay, so sin is equal to sin invalid escape sequence. No, just give me the... Oh, does this work? I don't even... Oh, crap. Command... There we go. Oh, it's been way too long since I've coded. Does this just print... Oh, okay, great, okay. And then cos is equal to cos. Left is equal to left. Right is equal to right. And this is a list or a coef list of ints or floats, I guess. And wait, hold on. Python rounding. Round. Okay, round. Okay. Oh no. Let me just edit my function then. Fourier coefficients. round, codon, normalize, and I'll round to 2 decimal places. That should maintain most of my things. Alright, let me just see if this works. Great. Okay, hold on. This is I mean, it's fine. Negative 0.0 is fine also. Yeah, I'll tidy that up later. Actually, I'll just make that function now. Def tidy list takes an list, which is a list of floats. This will do none. This uses aliasing. For I in length list. List of I. It's less than 0, 0. List I. Let's create a negative 0.01. List of I is equal to 0. That should be fine, actually. Tidy. Oh, oops. Range of length of list. None? Dog. Oh, whoops. Wait. Tidy list codef. And then this should work. Okay, and then now elif list remove any trailing zeros. Python remove trailing zeros from float. Okay, list I equals actually no, I'll just do this the hard way. Maybe let's see, what can I do? Strings equal to the string of list I. Okay. And then string dot find nums equals 9. I'll have for num in nums. All zeros equals false. Alright, I'll set it as true. If num in string all zeros equals false, and we'll break, and then nothing will happen. And then if all zeros I is equal to tail in tail strings equals string from going to string dot find If this works, oh, it works. Oh my god, okay. What? Oh, beautiful. Oh god, okay, okay. Alright, great, that works. Damn, awesome. Okay, so now I can do this one pretty easily. For in coefs. Or no, I'll do for I in the length range of the length of coefficients. I'm basically just doing the same thing as I am here, right? Okay, I'll use the same outline. Or I'll have the final string just be a list. I think that'll make it easier, because I'll just join it with a space afterwards. If coefs at I is equal to 0, then we'll just continue. Else, equals. Okay, so this should just have, yeah. Okay, else, this is sign, I don't need the increment. I just need, oh god, wait, keep it there. I'll have final string dot append plus Okay, here, I can make this version. If Desmos, then we're gonna watch this is gonna work. Okay, and then I'll do sin plus equals sin, and then cos plus equals cos. So if there's no Desmos, then I'll just leave that empty. Basically, if there's Desmos, then I just add these. But negative coefficients. Okay, first, coef equals coef dot copy, and I just want to for I in range of length of coef. I just want to filter this guy. If coef i's equal to 1, empty. What do you mean, unexpected type? Yeah, it's fine, I'm sure I'll figure it out. Okay, I think I know how they work then. Alright, that should be good. And then coefficient plus this plus this. Pi. String of co times I. Okay, that should work. And then this should be the exact same, just with cos. Okay, but I do a join. Not join final string. This should work. Let's see. Damn it. Oops. Okay, that was wrong. I is a what? Really? Oh. What? But this necessitates that. Oh. I completely. Okay. Int is equal to I plus divided by 2. That's my bad. I completely forgot that I is also the variable used in the thing. Something went wrong. It's pretty good though. It's not bad. But if there's 0, first of all, if there's 0, right? If this is 0, oh, probably okay, better. But why is it ignoring the very first item? Because there's still a plus. I guess it's if coef okay, this should work. Bam! Nice. Okay, so if let's say I change this to 2, this should still work. Great. If I change this to 1, this should still work. Awesome. Okay, what if I change this to true now? And so can I add this to Desmos? Please? Can I not paste copy paste into Desmos? Oh god, why can't I add? Please, no. No. Can I inspect? Set an option? Outer. It's in here. Give me the thing. I want in. Oh god, this is gonna be very annoying to edit. Are you being so for real? Did I do all of that work for nothing? Oh god. Oh god, why is this site so complicated? Ah, I see why. Because these, when I copy and paste these, aren't actual things. But they have a way to convert it, though, which is weird. So, what then? What do I do? What do I do? Matplotlib? I mean, I haven't learned Matplotlib yet, but okay. Well, either way, that's most things is kind of stupid. Then I'll comment this out and then I'll remove this. That's so sad. All right, so I can't exactly tell, but there is a silver lining, and that is doesn't really matter. It just makes my life a little harder. I want to approximate. I want the Fourier decomposition of x cubed plus 2x plus, or so let's say minus 2x plus 3. I want the Fourier decomposition of this function plus x squared minus x squared. Yeah. All right. I want to be able to decompose this guy. So this is how I'm going to do it. Basically, just going to edit this to do x minus index 2 minus index times 2 plus 3. Yeah, give me the first 7. Okay. Now let's see how accurate this is. Oh, this will be cool. 1.92 plus 0.69 sin 2 pi x plus 0.05 cos 2 pi x plus 0.33 sin 4 pi x plus 0.01 cos 4 pi x plus 0.22 sin 6 pi x plus 0.01 cos 6 pi x. Okay. Not overly impressed. Wait, what interval is this on? 0 and 1. Oh, that's pretty good. Oh, that's pretty good. That's so cool. What if I change this interval to like 0 to 2? Oh, that's so cool. Okay, I get a different function, obviously. Zero 0.95, 0.66, 0.03, 3301. Okay, that's impressive. But I'm sure if I like gave it like compute the first 100 for me. Oh god, okay. This is why if I could graph this so easily, it'd be so cool. I could just graph all of these functions. Can I give this to like ChatGPT or something? Can you graph this function for me, please? Also graph the function f at x is equal to x cubed minus x squared minus 2x. I know this is not what Fourier decomposition is meant to be for, but I'm just curious. Plus 3. In a different color. show this function on the interval 0 to 3. No, I did 0 to 2, right? This is so stupid. I'm curious. I don't know how it's gonna look. Like, if we can actually approximate this graph from 0 to 2, that'd be really crazy. Interesting. Huh. Can you now show this on the interval -1, -1 to 5, and also all y values from 2 to, let's say, 6. Because I want to see how accurate it is just for that little interval, but for everywhere else should be different, right? Okay. I'm not overly impressed. I mean, sure. Hey, I mean, we'll take it. So this is cool. This is so cool. Okay, so I actually did it. What are some cool functions Fourier decomposition can approximate? Number of times differentiable. Oh, interesting. Okay. So what's something that's infinitely differentiable? E to the x. Oh, I want to see if it can approximate e to the x. 2.716 times index. Wait, don't give me 100. Don't. Okay, actually just give me like 10. How good can it approximate? Because this is infinitely differentiable. Hey, so this is what you get. Note equals 2.64. I understand this is not for a this is like, this is meant to be good for, okay, it's not going to be very accurate. That's cool, I guess. But like, I can give it any like, okay, that's cool. Alright, so I ran out of time, but this is so interesting. For next time, okay, so I can cross this off. I can cross this off. And I've also figured out decomposition over A B, didn't I? Like, does this still work for all? Like, I don't actually know if this works for all A B. Because I don't think my. You know what? That actually might be why it didn't work. Wait. Sorry, I'm going a little over time. If I change this to 0 and 1. I can paste it in. Whoa. Oh my god, look how accurate it is. Wow. Oh, I can paste it in. What? Okay, wait, I can paste it in. Great. Bro, I could have pasted this in the whole time. This is so cool. Give me 100. Give me this. Empty list. Okay, alright, okay, fair. Okay, fine. I was a little greedy. Or was I? No, I'm gonna try it. Just give me up to that. Oh, that is so cool. It actually approximated. Wow. Okay, so no, I haven't generalized to 0 and or A and B is the answer. So I'll have to figure out the theory for that after. Wait, now I want to try so many different functions. Hold on. What's the... Okay, let me restrict my x to just 0 and 1. Y should be let's say negative 10. X should be negative 10. Minus x squared. I want it to be more interesting. Give me a more interesting function. Okay, I'll just define this by roots. X minus 0.1, x minus 0.5, x minus 0.7. Let's add a crazy coefficient. 100. Okay, this is what I want to approximate. Oh god, I don't know. Go away. F index. Okay. So it should be index, not x. Alright, run it. Give me the first 20. Okay, wait. I have to... What? It does match. What do you mean? Don't gaslight yourself, Desmos. Whoa. Whoa, that's so cool. Oh my god. Oh, that's so cool. Okay, why are you in purple? Can I make you also? Damn. Let's call this g at x. If I plot h at x, it's equal to f at x minus g at x. Wow. That's pretty accurate. Cool. That's so cool. Okay, I'm happy. This is really cool. Oh my god. Wow. Okay. So next time I'll generalize this to AB, and I'll start developing some of the theory, and then I'll also try to figure out a way to, I think, some sort of interface for sound, because I think this is a very interesting application of music. I want to see if I can give it 3 tones, right? And it'll make a chord. And as a musician myself, I'll be like, okay, that's that chord. And if it can actually like decompose each note, that'll be really interesting. I mean, you should be able to, but I want to be able to generalize it to that. And that's only after I can obviously do it across AB. So yeah, that's the plan for next time. Yeah, this is so exciting though. Great. Sorry, this is a lot longer than an hour, but like, oh, this is cool.